Following on from the previous video, we got to this stage here where we used Riemann's upper and lower sum to track this in between this and in between this. So what that means is, if we keep on adding each term here, if we keep on adding this term, add this term, add this term, add this term, we want to know the number of terms needed where the whole thing here adds up to 20. So put 20 into this Sn here. So now it is the end that we are seeking. It is the end that we're seeking. We want to know the number of terms needed in order for this partial series to add up to 20. So it is the end that we are seeking. We are seeking the capital N. So from here, so basically put 20 into here. So that will then take us to here. So now, hang on. So now let's just look at this part here. Let's forget about this for being. So 20 has to be bigger than this thing here. So now let's just look at this bit here. So now exponentiate equally to both sides. So n must be less than e to the power 20. Now let's look at this side. So forget about this for the time being. So let's just look at this side here. So it is the capital N that we are seeking. So take away 1 from both sides. That will then give us this. Exponentiate both sides. That will then give you this. So capital N must be bigger than e to the power of 19. So let's just rearrange these two. So remember, capital N must be less than e to the power of 20. So capital N must be less than e to the power of 20. And looking at this, capital N must be bigger than e to the power of 19. Capital N must be bigger than e to the power of 19. So what that means is capital N is somewhere in between here and in between here. It is somewhere in between here and in between here. So maybe you might want to make capital N to be bigger than this number here. Maybe 1, or maybe you can even keep it as this. But it's going to be somewhere around here. Okay, so you're going to need this number of terms in order to reach a sum of 20. Okay.